Okay, so for this lesson we're going to be factorizing quadratics, including difference of squares. So we often don't think of difference of squares as quadratics. So we're going to use magic numbers and squares to factor expressions. So I need you to write this down, so probably pause it, because I'm going to go straight to the examples, because that'll be a better way of explaining it than me talking about it. Okay, so every single example here looks like a square to me, okay? So some of them are obvious and some of them not so much, alright? So this one, yeah, 9 is definitely a square. Like if I went 3 squared, it's the same thing, okay? So I can go straight to the answer. It's just going to be a plus the square root of each one, alright? And then a minus. Okay, so it's as simple as that. Okay. This next one is the same thing, except it's got a number in front of the pronumeral as well, and we can square root both. What's the square root of 16? 4. And the square root of x squared is x. So we're going to go 4x, okay? And then we're going to go plus, and what is the square root of 81? 9. And the square root of y is obviously, y squared is obviously y. So we're just going to put y there. And then in the next bracket, we just need to go 4x minus 9y. Okay? So that's factorizing using difference of squares. So we shouldn't be stressing too much about it, but it's something we need to get used to it. Now this last one, question 3, I put it there on purpose. I just wanted to explore one other thing. Difference, in maths, it means takeaway, and that's what you're looking for. You're looking for takeaway and you're looking for 2 squares, and the square's there, okay? To factorize it. This one, square root of 40 and square root of 5, they're not that obvious, okay? So we're just going to write the symbol square root. So I'm going to go square root of 40 x, I'm going to put the bracket open, plus square root of 5 y. Now make sure that that square root doesn't keep going, because otherwise it's wrong, okay? And then we're going to go square root of 40 x minus square root of 5 y. Now if you wanted to be even cooler, you can keep going, because the square root of 40 is the same as saying, I'm going to write here, let's use green, square root of 40 is the same as saying square root of 10 times square root of 4, and we know what the square root of 4 is, don't we? Yeah, it is 2. Alright, so I'm going to go 2 root 10x plus square root of 5y 2 root 10x minus root 5y. Okay? If that last bit doesn't make too much sense, we'll work on it in class. But I know that you probably did a little bit of that in previous years. So have a go at those. Alright, this video is going to continue. We're going to use magic numbers to factorize quadratic expressions. So like this one, okay? Alright, so we're just going to use magic numbers to solve these. So what we want to do is that we want to get the factors of 12, alright, so factors of 12 that add up to 7. It's pretty easy, 3 and 4, 3 times 4 equals 12, 3 plus 4 equals 7, so we can go straight to the answer. X plus 3, x plus 4 will give us our roots, okay? Will give us it in factored form. It doesn't actually give us our roots, but it gives it to us in factored form. Okay, next one is we're looking at the factors of 36 that give us minus 13. Now this one's a bit trickier, but I'm looking at 36. I'm thinking 9 and 4, okay? But I need to get negative. 9 times 4 is 36, so let me write that down. I'm thinking negative 13. But what if I went minus 9 minus 4, because minus 9 times minus 4 still gives us a positive answer. Okay. If you need a bit more explanation of that, I will be in class ready to help you. But yeah, if you get it, just charge along. Okay. So that means the answer is going to be x minus 9, x minus 4, because 9 take away 4 is minus 13. So that's our answer. Alright, for question 3, there's a couple of ways we can do it, but I'll put it in there for one reason and one reason only. Okay? So, one thing I'm going to look at the next question later for another topic, but these two are monics, alright? We can put a 1 in front of them because that means 1x squared. Think of monobrow. Okay? That means you've got one eyebrow. Okay? So monics is we find factors, we see what it adds up to get the middle term, and we go straight to the answer. The ones that aren't monics, we have to follow a slightly different process. But the first thing I want you to do is to see something beforehand, okay? And hopefully somebody's already seen it. Each one of these terms, I can factor something out, all right? If you said 3, that's correct. So let's do that first. 3, and then we get x squared plus 12 plus 28, all right? So, and there should be an x there. Sorry about that. That was my mistake. If you're shouting at me, I totally deserve it. Okay? Now I'm looking for factors of 28 that will add up to 12. So, factors of 28 that will add up. And I've just realized that there's none that will add up to 12. If I change this to, instead of a let me see. Instead of a plus, it becomes a minus. So if I put that as a minus, then that means that this will become a minus 28. Okay. Now that will work. Okay. Because I can use factors of 14 times minus 2, okay? Because 14 times minus 2 is minus 28, and 14 take away 2 will give us 12x. I apologise for that. The main reason I put this example is that sometimes if you can clearly see a common factor in all 3 terms, that's what we have to do first. So we go 3, and then we go x plus 14, and then the other one x minus 2. Alright? Apologise for that. Okay, for this last one, we actually can't take a common factor from all 3 terms. So what are we going to do? Well, what we need to do is we need to multiply this non-monic with this constant term. So let's do it, and let's put it in brackets here, 24, okay? So now we're playing magic numbers, not with 12, but with our 24, okay? And we want to split this one open. And if I think of it, we've already been using, so if I go 6 times 4, that gives me 10. 8 times 3, yeah, 8 and 3 will give me there, so 8 and 3 is my factors. So this is the difference, this is where students usually get it wrong, is that what I need to do now is split the middle term because it's a non-monic. So I'm going to put non-monic. Okay, so I'm going to rewrite everything. 2a squared, but now I'm going to go plus 8x plus 3x plus 12. Okay, and now what I'm going to do is going to do partial factorization. I'm going to find out what, I've got a and x, so that's good. Let's change that to an a. I'm not doing well, am I? Let's change it to an a, and let's put that as an a. Okay, so what's common between both of these first ones? Well, there's two things. There's the 2 and then there's an A. So I'm going to take that out, 2A. And then I'm left with A plus 2 times 4 will give me 8. And then I've got to look for what's common between these two. And it's 3, just the number 3. So I'm going to go A, and then 3 times what equals 12? 4. Now that's really good. This is when you know that you've done it right, because these two should be exactly the same. So what I'm going to do is going to take this as a factor out. A plus 4, just bring it in its own bracket, open bracket, and put the rest in. 2A plus 3. Hopefully that helps. If not, and this is, don't feel bad about it. Like, this is a topic that students, like, they need practice over practice over practice to do again. Some of you are excellent at it, I'm sure. But if not, just practice and practice again and ask me in class. All right. All the best. Peace out.